A very good afternoon to all of you guys. Today we are back again to solve some questions of previous year JEE Advanced based on the topic quadratic equations and complex number. So, first of all, before moving ahead and talking about the questions, let me tell you that this is that quadratic equation and complex numbers is one of those chapters which has great weightage since there can be a vast variety of questions that can be asked. So I hope with the help of this session, you get to understand how to tackle questions as well as uh, there should be some sort of concept clearance as well. So let us wait for 2-3 minutes if there are any participants supposed to join. We'll start our session at sharp 3:05 p.m. Okay, guys, let us start our session. So today's the outline for today's session is previous year question discussion. And with this, let us start and move ahead with our first question. So all these questions have already been asked. All these questions have already been asked in JEE Advanced previously. So try to keep up and grasp everything you can throughout the session. So in the first question, it is saying that let alpha and beta be the roots of this equation x square minus 6x minus 2 equals to 0 with the condition that alpha is greater than beta if a of n is such a sequence of numbers that follows this pattern alpha power n minus beta power n for all n which is greater than 1, then we have been asked to find the value of a power 10 minus 2a power 8 upon 2a power 9. So to solve this, first of all, we know what a10 is, what a8 is, what a9 is, right? We can write it from this thing. A10 will be alpha power 10 minus beta power 10. A9 would be alpha power 9 minus beta power 9. And A8 will be alpha power 8 minus beta power 8. Okay. So from this quadratic equation, From this quadratic equation, since alpha beta happens to be the root of this quadratic equation, can I say that alpha plus beta, sum of the roots, which is like minus b by a in the general quadratic equation. So here minus b by a would be minus of minus 6 by a. It will come out to be 6. And alpha beta would be c by a. So c by a would be minus 2 by 1 and it will be minus 2. So we have got the values of alpha plus beta and alpha beta, right? Now we'll try to solve the question So we are supposed to find alpha power 10 minus beta power 10. We are supposed to find out A10 minus 2A8 divided by 2A9. So I am writing this thing in the terms of alpha beta as the series is given to us, sequence is known to us. So alpha power 10 minus beta power 10 will be A10, then minus 2 times of A8. A8 will be alpha power 8 minus beta power 8. Okay. So this is the numerator part and the denominator will be 2 times of alpha power 9 minus beta power 9. Okay. So now what we can do here is in the numerator, what I am doing, I am keeping alphas together. So alpha power 10 minus 2 times of alpha power 8. So here I'll keep this here with the alpha, like all the alphas together, add all the betas together as well. Okay. And I'm not going to do anything to the denominator. Why? You will just realize it in an instant why I am doing this. Because see in the equation here, alpha since alpha is the root of this equation, you can say that alpha square minus 6 alpha minus 2 is 0 and beta square minus 6 beta minus 2 is also 0. So using these two things, I can substitute alpha square minus 2 as 6 alpha and beta square minus 2 as 6 beta. So I'll be using this relation in here, and where and how we can use it is I'll take here alpha power 8 common. So inside it will be left with alpha square minus 2. Here I'll take beta power 8 common and here it will be left with beta square minus 2. And the denominator will be 2 alpha power 9 minus beta power 9. Okay. So now here you can see that alpha power 8 is alpha power 8 as well. Alpha power 8 is alpha power 8 itself. Now alpha square minus 2 can be written as 6 alpha, right? And beta power 8 will be beta power 8 itself. And but beta square minus 2, this part and this part, this is 6 alpha, this is 6 beta, right? From this equation, yeah? From the quadratic equation, we are getting this. So I'll write it as 6 beta upon 2 alpha power 9 minus beta power 9. Okay. So you can see that this equation has been reduced like in a very simple fashion now. This becomes 6 alpha power 9 minus 6 beta power 9 upon 2 times alpha power 9 minus beta power 9. So you can take 6 by 2 common and numerator and denominator will become equal. So this will get cancelled. What remains is 3 itself. So the answer to this question is 3, which is option C. Okay. So as you can see, this question didn't require like very difficult concept understanding or graphical analysis or something like that. It was simply based on pure algebra or arithmetic, and there was trick to substitute the appropriate values to get to the answer. So sometimes it's just arithmetical question also. So JEE advanced doesn't mean always the question will be highly conceptual and highly graphical or highly analytical. So in this fashion, these type of questions occur like more frequently, and wherein people get confused. But here you should not get confused. It is very simple. Let's move ahead with our next question. Okay, now in this question, you can see that x square plus px minus 444 has integral roots where p is a prime number. Then the values of p is r. So this question has given us a condition in where the quadratic equation has integral roots. Okay. The quadratic equation has integral roots when p is a prime number. Then the possible values of p. So what can be the values of p? Okay. So this is our question. So first of all, since it has integral roots, what is the first thing that comes to our mind is that the discriminant should be equals to 0, right? That the discriminant should be equals to 0. Sorry, that the discriminant should be a perfect square, right? So now, what is the discriminant value? What is the discriminant value? Discriminant value is p square minus 4 times 444p, and b square minus 4ac. So this should be a perfect square. So to have this thing as a perfect square, like can I write this p into p minus 4 into 4 into 111 equals to perfect square. So this should be a perfect square. Sorry, this becomes plus, this becomes plus. So what is the value of uh 16 into 111? This is p square plus 1776p, right? This should be a perfect square. So after you take p common, you will get p plus 1776. Should be a perfect square. Now, if this is a perfect square, if this is a perfect square, then p plus 1776 should be a multiple, of p, right? Otherwise, this is not possible. So p plus 1776 should be a multiple of p. Otherwise, this is not possible. And if p plus 1776 is a multiple of p, then 1776 should also be a multiple of p, so that this p factor comes out, right? So first of all, let us try to factorize 1776. 1776 can be written as like 4 into 4 into 111. So I'll factorize it a bit further. So it will become 4 into 4 into 111 is 3 into 37, right? So this becomes 4, 4, 16, 2 power 4 into 3 into 37. So now, so this thing 1776 can be a multiple of these, like the factors which have come here, right? It can be a multiple of 2, it can be a multiple of 3, it can be a multiple of 37, it can be a multiple of all these numbers, as well as like combined 2 3 the 6, 337 like this, right? Now p here can be 2 3 37 like this, right? So when you put p, when you take p as 2, then d comes out to be, what will be the value of d? It will be 4 plus 1776 into 2. So this won't be a perfect square, not a perfect square. If you check, then this won't come out to be a perfect square, You take 2 common, this will become 2, like 1778. 2 into 1778. So this doesn't come out to be perfect square, right? You can check. Now after this, if you put p value as 3, so the discriminant, which is 9 plus 1776 into 3. This again, this will come out to be 3 into 1779, right? So this cannot be, this you can factorize and you will find out that this is also not a perfect square. So now we are left only with 37. So when you put 37, so the value will be, so the value will be 37 plus 1776 into 37. So in the next slide, I'll be writing now. So 37 into 1 plus, this will be 37 square. Here it should be 37 square. So 37 square plus 1776 into 37. Is this a perfect square or not? We have to check. So what I'll do, I'll take 37 common. Here it will be 37 plus 1776. You will get 37. Here you will get, see, this is 37 and 1776 was 37 into, you can see we had factorized 1776, right? It was 37 into 3 into 2 power 4, right? So this was 37 into 3 into 2 power 4. So now it becomes 37. And you can take 37 common again. It will be 1 plus 3 into 2 power 4. So this will come out to be 37 into 37. 16 3 is a 48 and 1 49. So you can see this is the square of, this is a, as you can see 49 is a perfect square. 37 becomes a perfect square. So this becomes a perfect square. So the only possible value for P is 37. So that the discriminant becomes a perfect square. So that is why our answer is option D, which is 37. Okay. So here this question was, guys, a little analytical. You had to think which values P can take so that this condition is satisfied. So the main thing to remember is whenever a quadratic equation has integral roots, D value should be a perfect square, then only it is possible. The least condition that you can use is D should be a perfect square, right? Okay. I hope you guys understood this question. Let us let us move ahead with the next question. Okay. Now here, what has been given to us is, let theta belong to this interval minus pi by 6 to pi minus pi by 12. Suppose alpha 1 beta 1 are the roots of the equation x square minus 2x theta plus 1 equals to 0, and alpha 2 beta 2 are the roots of this equation. So if alpha 1 is greater than beta 1 and alpha 2 is greater than beta 2, then the value of alpha 1 plus beta 2. Okay. So first of all, here alpha 1 plus beta 1 from the first equation, what you can write? You can write 2 sec theta, and alpha 1 beta 1 will be equals to 1, right? Okay. Now from the another equation, you can write alpha 2 plus beta 2 equals to minus 2 tan theta, and alpha 2 beta 2 will be equals to minus 1 again. Okay. So from the first quadratic equation, I'll be mark from the first quadratic equation and from the second quadratic equation, we have derived two results. Now, the given condition is alpha 1 is greater than beta 1 and alpha 2 is greater than beta 2, and we are supposed to find alpha 1 plus beta 2 value. Okay. So to find alpha 1 plus beta 2 value, what you can do here is, first of all, like in the first quadratic equation, let us try to find out what can be the roots of this equation. So for x square minus 2x sec theta plus 1 equals to 0, I will be using the quadratic formula. So it is x is minus of b plus minus under root b square, which is 4 sec square theta minus 4ac, which will be 4 in this case, and this will be upon 2, right? So this will become 2, this will become 2 sec theta plus minus under root of 4. 4 will come out to be 2. Like 4 will come out of the root and it will become 2, and inside it will remain sec square theta minus 1. So we know that 1 plus tan square theta, we know that 1 plus tan square theta is equals to sec square theta. So sec square theta minus 1 will be tan square theta, right? And here it was upon 2. So these 2's will get cancelled. Now here it will be sec theta plus minus tan theta, right? Similarly, for the second quadratic equation, x square plus 2x tan theta minus 1 equals to 0, right? In this thing, the x value will be minus b plus minus under root b square minus 4ac upon 2. Here minus 2 tan theta plus minus, here it will be 4 will come out and the insides will be tan square theta plus 1. The inside of the root will remain like this. So now tan square theta plus 1 is sec square theta, right? So here it will be minus 2 tan theta plus minus 2 times sec theta upon 2. So 2 will again get cancelled. So this time the x value comes out to be minus tan theta plus minus 2 sec theta. Now the condition alpha 1 is greater than beta 1 and alpha 2 is greater than beta 2 is given to us because we can tell exactly out of these two roots, which will be like out of these two roots, which will be alpha 1 and beta 1, and out of these two roots, which will be alpha 2 and beta 2. So for this purpose, this is given. And to find out this information, like to find out exactly which root will be bigger than the other root, the range is given to us, right? Theta is being specified, theta has been. So I'll be writing the roots again in the next slide. Sec, this 2 is not here. So sec theta and minus tan theta. Okay. So for the first, like for the first quadratic, it had roots alpha 1, comma beta 1, right? So these roots were sec theta plus minus tan theta, and alpha 2 comma beta 2, these two roots were minus tan theta plus minus sec theta, right? So we are supposed to find out which root is like out of these two, which is alpha 1 and which is beta 1. So theta value is specified to us as minus pi by 6 to minus pi by 12, right? So now, first of all, where does this minus pi by 6 to pi by 12 lie, right? So that should be our question. So you can see that minus pi by 6 to pi by 12. So this is like 0. This is minus pi, right? Minus pi by 2. So in this fourth quadrant, fourth quadrant, uh, this minus pi by 6 to minus pi by 12 will lie in between fourth quadrant, because pi by 6 and pi by 12 both are less than pi by 2. So somewhere in this fourth quadrant, those angles would have passed. So fourth quadrant, the theta will lie in the fourth quadrant. Now in the fourth quadrant, we know that cos theta is positive, and we know that cos theta is positive. So therefore sec theta will be positive and tan theta is negative, right? So sec theta minus sec theta minus sec theta. So the two values which are sec theta plus tan theta and sec theta minus tan theta. So in this tan sec theta is positive and this is negative. So sec theta plus tan theta will be less than this sec theta, right? So this will be less than sec theta and this will be greater than sec theta. So that is why the bigger root, which is sec theta minus tan theta, sec theta minus tan theta is alpha 1 and sec theta plus tan theta is beta 1. Now for the other part, you can see minus tan theta plus sec theta and minus tan theta minus sec theta. Now again, minus tan theta is positive. So to this positive number, sec theta is added, right? So to this positive number, sec theta is added. That means what? Sec theta is also positive. This is also positive. So this will come out to be positive increase. This will increase. Now to this minus tan theta, the same quantity is subtracted, like subtracted. So that is why this will be this will be greater than the minus tan theta minus sec theta. So in this scenario, alpha 2 was greater than beta 2, right? So alpha 2 will be minus tan theta plus sec theta and beta 2 will be minus tan theta minus sec theta. So now what are we supposed to find? We are supposed to find the sum of alpha 1 and beta 2. So alpha 1 is sec theta minus tan theta and beta 2 is minus sec theta minus tan theta, right? So alpha 1 plus beta 2 will be sec theta minus tan theta minus sec theta. So this will get cancelled. So alpha 1 plus beta 2 comes out to be minus 2 times of tan theta. So guys, in this quadratic, the analysis of the angle, in this question, the analysis of the angle, the angle where it lies, and due to that, what effect it has on the roots was essential. If you would have done this analysis, it would have become easier for you to understand. Apart from this analysis, the other things were pretty easy to understand, right? So, so the answer is minus 2 tan theta, which is option C. So I hope you guys understood the question and the solution. Let us try this question. So this question So guys, this question is pretty easy compared to the questions that we have done till now. So in this question, what is given to us is that if alpha is the root of equation 2x into 2x plus 1 equals to 1, then the other root is. We have to find out the other root in terms of alpha itself. So here if alpha is the root of this equation, then what can be the other root? So first of all, let us try to write the equation. This will become 4x square plus 2x minus 1 equals to 0, right? So I'll say let alpha and the other root be beta. So I'll get from this, since alpha is the root, I can write, since alpha is the root, I can write what? Since alpha is the root of the equation, I can write 2 alpha into alpha plus 1 equals to 1, right? I can use this. I have applied this alpha in this equation itself. So what now I'll do is, I'll get the value of alpha into 2 alpha plus 1 will be 1 by 2, right? And now, you know that the sum of the roots alpha plus beta is minus 1 by 2. Okay. So what we will do here is I will substitute the value of alpha. I will substitute the value of alpha like this. Beta will become minus half minus alpha, right? Now here it will become alpha into 2 alpha plus 1 equals to half. So half I can write it as minus of alpha minus of, I am using this half and I am writing minus of alpha plus beta. So the beta value, what I can do here now is this has become very easy. So this was not necessary as well. So now I have gotten the equation in terms of beta. So I can write alpha into 2 alpha plus 1 will be equals to minus alpha minus beta. And then I can send the bit. I can, what I'll do here is I'll keep the beta here itself. I will write 2 alpha plus 1 plus alpha equals to minus beta. I have sent this alpha this side. So I'll take out alpha common. This will become 2 alpha plus 1 equals to minus beta. Now from this, you can see what I'll do here. I'll write alpha into 2 alpha plus 2 equals to minus beta. 2 will come out, so it will become 2 alpha into alpha plus 1 equals to minus beta. So beta value that we found out in terms of alpha is minus 2 alpha into alpha plus 1. So this was not very difficult, guys. So we found out our beta value to be minus 2 alpha into 2 alpha into alpha plus 1, right? So did you guys, like, for this question there was no catch, no trick. The only, like, I think the only thing to realize was that you have to like write down the equation of alpha using the quadratic itself and use the sum of the roots condition, since the sum of the roots had equal value to this particular thing, right? So in this fashion you could have done the question very easily. So by far you must have seen that most of the question, like except for one question which had a little trigonometrical analysis, all the quadratic questions were pretty much arithmetical questions, and a little bit of concept was required to solve those questions. So to solve these type of questions, practice is essential. You should have practiced a lot of question to know the tricks to move the variables and constants to get to the answer. Now, a value of b for which the equations, a value of b for which the equations have one root in common is, okay. So guys, this question is entirely based on that property alpha square, when the condition of one common root. Do you guys remember the condition of one common root? So if you remember the condition of one common root, you wouldn't have had to face difficulty in solving this question. So what was the condition of one common root? If you remember, it was something like alpha square upon equals to alpha upon something equals to 1 upon something, right? So how to determine what this something was, right? So like for two quadratic equation, a1 x plus b1, a1 x square plus b1 x plus c 1, and a2 x square plus b2 x plus c2, the condition was alpha square upon b1 c2 minus c1 b2, and here alpha upon a1 c2 minus a2 c1, a2 c1 minus a1 c2, and 1 upon a1 b2 minus a2 b1. So if you guys remember this condition, then you can solve the questions of one common root. Okay. So here in this question, like let us assume that the common root is alpha, right? So alpha square upon, in this question, what is b1? B1 is b and c2 is b. So it will become b square plus 1 equals to alpha upon minus 1 minus b equals to 1 upon 1 minus b. So from the first, like from this condition, from the first and third part, you can get alpha square value as b square plus 1 upon 1 minus b, right? And alpha value you can write as minus 1 minus b upon 1 minus b. This will become b plus 1 upon b minus 1, right? So we will substitute this b plus 1 upon b minus 1 in this equation. We will use these two and try to solve, right? So let me write it down again. Alpha square value came out to be b square plus 1 upon 1 minus b, and alpha value came out to be b plus 1 upon b minus 1. So I am substituting this alpha value in this equation, right? I am substituting this alpha value in this equation, and I'll get b plus 1 upon b minus 1 whole square equals to b square plus 1 upon 1 minus b. So this thing will become b plus 1 whole square, and b minus 1 whole square can be written as 1 minus b whole square as well, right? So this will be b square plus 1 upon 1 minus b. So this 1 minus b will be cancelled by 1 minus b, considering that b is not equal to 1. If b is not equal to 1, then we can cancel this and we will try to solve the question ahead. We will get b plus 1 whole square equals to b square plus 1 into 1 minus b, right? So after simplifying this, you will get b square plus 2b plus 1 equals to b square plus 1 minus b cube minus b. So b square plus 1 will get cancelled. You will get 3b equals to minus b cube, right? So you will get b cube plus 3b equals to 0. Take b square, take b common out. You will get b square plus 3 equals to 0. So the values of b that is possible are b can be 0 and b square plus 3 is 0. In this case, b will be root 3i. Right, guys? So let us check. So a value of b for which this is possible is, this will be, sorry, here it will be b square equals to minus 3, then b will be plus minus root 3i, right? So one value of b that is possible out of the given option is option B, minus root 3i. So the answer to this question is minus root 3i. Apart from that, b equals to 0 was also a possible answer. Apart from that, b equals to 0 was also a possible answer, but the question is a value of b. Like they are asking for one value of b out of the given options. Now, this question is very basic, but scoring. So in this question, what we can do here? So you can make cases and try to solve, right? So in this question, first of all, you should understand that it is saying mod of A plus mod of B is equals to C, right? It is of this type, right? So when the mod of two values are added, then automatically C comes out to be, like, we should know that C cannot be negative. C should always be greater than or equal to 0. So that is why can I say that x minus 3 will always be greater than or equal to 0, and hence x will be always greater than or equal to 3, right? So now if x is always greater than or equal to 3, then mod of x minus 1, na? For this, mod of x minus 1 will always be x minus 1, and x square minus 3x plus 2. X square minus 3x plus 2 is positive when x minus 1 into x minus 2 is greater than 0. So when x is greater than equals to 2 or x is less than equals to 1. So when x is greater than 2, this equation is also like this x square minus 3x. This mod will also be always positive. So can I say that x square minus 3x plus 2 will always be equals to mod of x square minus 3x plus 2 will be equals to mod of x square minus 3x plus 2 itself, like, sorry, that equation itself. Why this has happened is because under this condition x minus 1 is positive and this is also positive. So whenever mod x is positive, sorry, the value of x is positive, then mod x is equals to x, And whenever it is negative, it is equals to minus x for x is less than 0. Right, guys? So we have used this property and applied here to understand that mod of x minus 1 will be x minus 1 itself, and x square minus 3x plus 2 will be mod of x square minus 3x plus 2 will be x square minus 3x plus 2 itself. Right? So now we will again go back to the equation that is given to us in the question and try to solve it after analyzing all this part. So the equation will become x square minus 3x plus 2 plus x minus 1 equals to x minus 3. So this x will cancel this x. Now this will become x square minus 3x plus 2 minus 1 is 1, 1 plus 3 will become 4 equals to 0. Now this, in this quadratic equation you can see that the discriminant is b square minus 4ac, which is less than 0. So that is why this can never be equal to 0. So there are no x's that satisfy the equation. So the answer will be x is element of phi or null set, right? So in this question, what was the trick or what was the important part that you guys had to like catch and understand was that the left hand side is the sum of two modulus and the right hand side is a linear polynomial. So when you sum two moduluses, then the output will always be positive, which means that right hand side should always be positive. That is why the first condition automatically comes to us is that x minus 3 is always positive, right? So this is the first condition we analyzed and came to a conclusion. So x is greater than equal to 3. Now, when you have found out that x is greater than equal to 3, then what should we do? Then after x is greater than equal to 3, we will analyze what happens to this modulus. So this modulus clearly is always like the input is always positive for x greater than 3, hence directly written down as x minus 1. And for this modulus also I have analyzed it here. As you can see, it was negative for only for only 1 to 2 input values for only 1 to 2. But our condition was x greater than 3. That means this is also always positive. Hence, I have written it exactly as it was supposed to be. So after solving this thing, we got that the quadratic that is formed has discriminant less than 0. And hence, since the discriminant is 0, there cannot be any x's that satisfy the equation. So therefore, the answer is null set. Okay. This was a quick summary. I hope you guys understood this question. Let us move on to the next question. Okay. Now let D be a square plus b square plus c square. AB being consecutive integers and C is equals to AB. Then under root of D is. So here you have to analyze. So this question is purely analysis question. Now since A and B are consecutive, A and B are consecutive, so can I write B is equals to A plus 1, right? And C is given to us as AB, right? So the equation D becomes A square plus B is equals to A plus 1. So plus AB square, right? So this becomes A square plus 2A plus 1 plus A square B square. So this will become 2A square plus 2A plus 1 plus A square B square, right? And this here you can take 2A common. You will get A plus 1 plus 1 plus I am writing this as AB square, right? Now we know that 2A is, we cannot do anything to this 2A, but this A plus 1, this A plus 1 is equals to B, right? So can I write it as 2AB plus 1 plus AB, right? So AB square. Now what has this become? Like consider AB as C, right? So consider AB as C. Now, so this has become 2C plus 1 plus C square, which is equals to C plus 1 whole square. So now D has become C plus 1 whole square, right? We know that D is C plus 1 whole square. Now since A and B are consecutive integers, A and B are consecutive integers, one of them, like one of them is supposed to be even and one will be odd, right? So since A and B are consecutive integers, either of A or B, one of them will be even and one will be odd. So that means their product AB, either one is odd or even. So C, which is AB, this will be even, right? Product of an even number or product of an odd number. So this will be even. So C plus 1 will always be odd. C plus 1 will be odd. So C plus 1 whole square will also be equals to odd number, right? So now let us come back to the value of D. So under root D will be equals to mod of C plus 1, right? Now mod of C plus 1, C will be an integer, right? That we already know. So always an even integer. Can we say that mod of C plus 1 will always be an even integer? No, we cannot say that. Always be an odd integer. Always be an odd integer. Can we say? Yes, we can say that always. Sometimes an odd integer, sometimes not. No, it is always an odd integer. Sometimes a rational number, sometimes not. No, it is always an odd integer, right? So we found out that since C plus 1 is odd number, so this will be odd integer, right? Since C plus 1 was odd, under root D would be odd integer itself. Correct, guys? So this question was very analytical, and this question was also very conceptual. The concepts being very basics, like the multiplication of even and odd is odd, addition of 1 to an odd is even, and 1 to an even is odd, like that. So those were very basic concept that was required, and a little bit of analysis. Now, let us move on to our next question. Now the question is, if 2 plus I root 3 is a root of the equation where P and Q are real, then PQ, the set, like the numbers P and Q equals what? Now, so for a quadratic equation, see, now in this question, you must know one concept, which is what the concept is that in a quadratic equation, in a quadratic equation, the complex root always appear in conjugate pairs, right? What does this mean? That let us say the given root is alpha. 2 plus I root 3. So the other root, since being conjugate to this alpha, will be 2 minus I root 3, right? Now, we know that alpha plus beta, sum of the roots of this quadratic equation will be minus p, and alpha into beta, product of the roots, will be equals to q. So to find the value of p and q, we need to find the value of sum of the roots and product of the roots. So let's come to the roots and try to find out alpha plus beta. Alpha plus beta will be 2 plus I root 3 plus 2 minus I root 3. So this I root 3 gets cancelled. What remains is 4, right? And alpha plus beta value is equals to what? Minus p. So this minus p will be equals to 4, and hence from this thing we get the value of p, which is equals to minus 4. So p value comes out to be minus 4. Similarly, to analyze the value of, to get to the value of q, we have to multiply the roots. Alpha beta. Alpha beta will be 2 plus root 3I into 2 minus root 3I. Correct? So this will be, this is a plus b into a minus b format. So this will be a square minus b square, which will be 2 square minus of root 3I square. So this will be 4 minus root 3I square is I square into 3, right? So this will be 4 minus I square is minus 1 and 3. This will become 4 plus 3, which is 7. Now alpha beta value is 7, and we also know alpha beta is equals to q from the quadratic equation. So our value of q will be 7, right? And the value of p that we found out, p was minus 4 and q was 7. So the answer pq will be minus 4 comma 7. Correct, guys? So this was pretty easy, right? The only concept that was required to understand this question was, in a quadratic equation, the complex root always appear in conjugate pairs. Okay. So this is a concept that is taught to us when we are studying quadratic equation, right? So slowly and steadily, we are transitioning our questions to complex numbers, so that tomorrow we will cover most of the questions on complex numbers. Today, the focus was on quadratic equation. Tomorrow, the focus will be more on complex numbers. Okay, guys? Let us move ahead and try to solve another question. If the product of the roots of this equation, x square minus 3kx plus 2e power 2 log k minus 1 is equals to 0 is 7, then the roots are real for k equal to what? So there are two conditions which has been given to us. There is two condition which has been given to us. First is, there is two condition which is given to us. First is that the product of these roots should be equal to 7, and the roots are real for what value of k. So we have to find out k from this condition, and then we have to find out for which value of k the roots will be actually real. Okay. So here the question will become x square minus 3kx plus 2e square log k minus 1 equals to 0. Now, here we all know that, can I write this as x square minus 3kx plus 2 times 2 log k is in the power. So we know that 2 log k means log of k square, right? Minus 1 equals to 0. Now we also know that we also know one more condition, that this thing e power log k square can be written as k square minus 1 equals to 0. Why? Because guys, first of all, you should know that e power log x is equals to x, right? When the base is e. So I have assumed the base to be e. When it is not given, I have assumed it to be e, right? So I can write e power log x base e equals to x. So I have used this condition and I have applied here to reduce it to k square. So now the equation has become what? X square minus 3kx plus 2k square minus 1 is 0. So in this quadratic equation, what has been given to us? That the product of the roots is 7. So product of the roots, let us say that this equation has two roots alpha and beta. So the product of the roots alpha beta will be equal to 2k square minus 1, right? C by A. So this will be 2k square minus 1. Now 2k square minus 1 is supposed to be 7. So 2k square will be 8, k square will be 4, and the value of k will become plus minus 2. Now after getting the value of k as plus minus 2, we are also supposed to check whether plus 2 makes the roots real or minus 2 makes the roots real. So we will apply it and we will write when k is 2. So x square minus 6x plus 7, this will become. Now when the value of k is minus 2, it will become x square plus 6x plus 7 equals to 0, right? So you are seeing that the both the quadratic equation are having real roots, but you should also remember that here e power 2 log k was given. So k was an input of log function. So since k was an input of log function, so here, from here the condition establishes that k cannot be less than 0, cannot be less than equal to, sorry, cannot be less than equal to 0. So k should always be positive. Hence, we take k value as 2 itself. Hence, we take k value as 2. Why? Because k is greater than 0 for log k. Okay. So that is why the answer is option B, which is equal to 2. Okay, guys. I hope you guys could understand this question. Let us move on. Let us move on to the next question. Now here, see, this is a question where students will think that, see, this Okay. Okay. So, hello guys. Sorry, I think the mic was muted. X square plus, so these two quadratic equation have one root in common. So what I am telling you is you can go through this tedious method. This is a tedious method, right? This requires a lot of calculation. So I am just writing the condition of one common root again. So the condition of one common root was here it will be a1 b2 minus b2 a1. Okay. So you can solve it. You can solve and get to the answer through this method also, right? But I would suggest you to be a little bit of more observing student and try to observe here in these two quadratic equation, like what is like one thing, like something looks familiar, something looks, both the quadratic equation have something like familiar. So what is that familiarity? For x equals to 1, the output is same for both the equation. So since these two quadratic equation are different quadratic equation, the output at one will be should have been different. But if it is, but if it is, but if it is same, 1 plus a plus b and 1 plus a plus b, that means that common root, that means that common root, that means that common root is 1 for which both the values of the equation are similar, which is equals to 0. And when the common root is 1, a plus b will be equals to minus 1. A plus b will be equal to minus 1. So this question was very easy to, like, if you could have seen the familiarity of those two equations, you would have realized that it is very easy to understand this question and solve it. Okay, so anyone who would solve this question through this method will also get to the answer, right? Will also get to the answer. So I'll just try to solve it through that method and I'll write it down. Let alpha be my common root. Let alpha be my common root. So alpha square upon b1 c2. b1 c2 will be a square minus c1 b2 minus b square equals to alpha upon c1 a2. C1 A2. So B minus A2 C1. 1 C1 A2 minus A1 C2. So A1 is 1 and C2 is A equals to 1 upon A1 B2. 1 into B minus B2 A1. B2 A1 B2 minus B1 A2. B1 A2 minus A. Right? So here you get, from here you can see that alpha square upon alpha square a square minus b square is equals to 1 by b minus a. So here you can get alpha equals to alpha minus beta a minus b into a plus b upon b minus a. So you will get alpha value to be minus of a plus b. And when you solve the last two part, you will get, when you solve this last two part, you will get alpha value to be equals to 1, right? So so the alpha value, like when we put alpha value as 1, you get again the same condition. A plus b will be equal to minus 1, right? A plus b will be equal to minus 1. Okay, guys. Now, in this question, if the least and the largest possible value, if the least and the largest possible value of alpha for which the equation z plus 8 alpha times mod z minus 1 plus 2y is 0 has a solution Rp and Q respectively, then the value of 4 times P square plus Q square is equals to what? So, okay, so we have touched complex numbers. Today this will be the last question that we discuss, and after this, we will continue complex number tomorrow and try to solve some interesting questions on complex number. So here what is it saying that if the least and the largest real values of alpha for which the equation z plus alpha times mod of z minus 1 plus 2I equals to 0 has a solution. So what I'll do here is first I'll say let us assume that z is equals to x plus iy. So z will become x plus iy plus alpha times mod of z minus 1 is what? Z minus 1 will be x minus 1 plus iy. So mod of z minus 1 will be x square plus x minus 1 square plus y square. I will simply write it here plus 2y equals to 0, right? So now this will become x plus alpha times x square plus 1 minus 2x plus y square plus 2y. Now this, what will it become? This is the real part, right? This is all the real part. So this will come out to be x plus alpha times x square minus 2x plus y square plus 1 plus 2y plus 2 times I equals to 0. Modulus will be root root here. So from, if you compare, if this is supposed to be 0, if this equation is supposed to be 0, then the real part as well as the imaginary part should be 0. So you will get y value as minus 2, right? You will get y value as minus 2 because y plus 2 should be equals to 0, correct? So after substituting y value as minus 2, what do we get here is x plus alpha times under root. This will become x square minus 2x plus 2 square plus 1. This will become 5. This will be equals to 0. I'll take this that side. I'll take this that side and I'll square. So this will become x square equals to alpha square into x square minus 2x plus 5. So now what I'll do is this will become I'm taking this x square to that side. So this will turn out to be x square into alpha square minus 1 minus 2 alpha square into x plus 5 alpha square equals to 0, right? Since x is element of R, right? Because for this complex number to be x plus iy, we have assumed that x is real part and y is imaginary part, but x and y both are supposed to be element of real number. Since x is element of R, the discriminant, since it is a quadratic in x, the discriminant here should be greater than equal to 0, right? So what is the quadratic equation that we have found? Alpha square minus 1 minus 2 alpha square x plus 5 alpha square equals to 0. So here d should be greater than equals to 0 for the x to be element of R. So what is the d value? D value is b square minus 4ac. So b square is 2 alpha square minus 2 alpha square square minus 4 times ac. A is alpha square minus 1 and c is 5 alpha square equals to 0. So let us say that alpha square is t. So what do we get here is 4t. So we get here 4t square minus 4 times t minus 1 into 5t equals to 0. So you get 4 will get cancelled. You will get t square minus 5t square plus 5t equals to 0. This is minus 4t square plus 5t equals to 0. So the t value, you will get 4t square minus 5t equals to 0. So what do we get here is t value. T into 4t minus 5 is 0. So t value can be 0 or t value can be 5 by 4, right? So here you can say that alpha square is element of 0 to 5 by 4, right? This is this was greater than 0, greater than 0. This was greater than 0, greater than 0, greater than 0. So we were solving for greater than equal to 0, greater than equal to 0. Since we change the sign here, this will become less than equal to 0, less than. So t value or alpha square value will be element of 0 to 5 by 4. 5 by 4. So the least value of alpha will be equals to 0 and the highest value of alpha, least value will be p, and the highest value of alpha will be equals to 5 by 4, which will be equals to q. So 4 times p square plus q square will be equals to 4 times 0 plus 5 by 4, right? So this will be 5, right? The answer is 5, guys. Thank you so much for watching, guys. We will meet tomorrow again with the questions of complex numbers. I hope you guys had fun in the session and you guys learned a lot. Thank you so much for attending.